7 today. And we were talking about exponential growth and decay. All right, so yesterday the equation I gave you that we started talking about was in the form y equals ab to the x. And we said that a was your y-intercept or your starting amount. So if we called it the starting amount, we can also call that your initial value. Initial, start, same thing, right? So your initial value is your a. Your b is your, what we call the growth factor. If it's a growth factor, that means b has to be bigger than 1. If it's a decay factor, then b has to be between 0 and 1. And we talked about that yesterday. So really, example number 1 and 2 go off of what you knew from yesterday. So example number 1, super, super easy. Let me get to the right page. All right, this is 9 through 12, and yes, we are doing all today, but some of them are so super easy. All right, 9 through 12, state the initial value and growth factor. And you're going to be given an equation. So let's say you have the equation y equals 7 times 3 to the x. You start off by saying a equals 7 and b equals, b is the number that's the base to the exponent, 3. Exactly, right? Let's try another one. What if I had y equals 2.5 times 5 to the x? What is a? 2.5, correct? And what is b? 5. Awesome. Let me throw one more. Yes. It's okay, we're good. All right. So I want to throw one more in this example just because I got to give it a little bit tougher. What if you just had 10 to the x? Good try. A is 1. Good. A is 1. And b, remember, b is the base to your exponent. B is 10. So you can imagine there's that imaginary 1 that's in front of your 10. Okay? All right. That being said, let's go to example number 2. Now, I know this is going to sound weird, but we're going to jump all the way down to 23 through 26 real quick. State the initial value and the decay factor. So I have y equals 12 times 1/2 to the x. My a value is 12, and my b value this time is 1/2. It's a decay factor because it's between 0 and 1. All right, so if I have y equals 0.5 times 1/3 to the x, what's my a value? 0.5. What is my b value? 1/3. All right, so those 8 problems seem pretty easy, correct? Okay? All right, so now we're going to talk about another equation. So we started off with that equation, y equals ab to the x. So that equation can have some variations to it. The first variation is if I have y equals a b to the x, and b is a multiple. All right, so I want to show you how we're going to set it up if it's a multiple. All right, so example number 3. Let's say I have 10 rabbits. The number of bunnies doubles every 6 months. How many will there be in 2 years? Not even that long a time. So when we plug it into this equation, we have y equals our starting amount, our a value is how many we start with, which in this case is 10. It's going to double, so our b value is our multiple. And then our exponent is the number of times it's going to happen. So let's talk about that. Happens 4 times, right? Every 6 months for 2 years. So it's going to happen 4 times. So now you just got to plug that in your calculator, or you can do it longhand. 2 to the 4th power is 16. And 16 times 10, 160. So we have 160 cute little rabbits in 2 years. Yeah. Well, I definitely wouldn't want 160 of them. All right. So we're all clear with that. But there's a variation to that equation now. What if instead of it being like doubles or triples, it gives it to you in a percent? Okay, so it changes our equation a little bit. So if given growth factor as a percent, then our equation is y equals a parenthesis 1 plus our percent as a decimal to the t. So this a is, of course, your start, however many you have to start with. Your r is your rate, but you have to change it as a decimal. And the t is time. All right, so here we go with example number 4, which will help with 13 and 14. Let's say I have 100 squirrels. I don't know.
Mister, what was example 3 helpful with?
You're going to see in a second. God trust me. I'm just trying to show you the difference. Yeah. Okay, I have 100 squirrels, and let's say that they increase at a rate of 22% each year for 5 years. So their population increases by 22% each year for 5 years. So we have y equals, we start with 100 squirrels, parenthesis, that it's 1 plus our percent is a decimal. How do I make 22% a decimal? Yep, you move it over 2, so it's 0.22. And it happens 5 years. So grab your calculator. Somebody plug that in and tell me what we get. 270. Okay. So let me ask you this. If We have 270.27 squirrels. Can I have 0.27 of a squirrel? Yeah, so let's round that up and say we have 271 squirrels. If you've got part of a squirrel, you've got the whole squirrel. Because if it's not living, then it hasn't been counted, right? Okay. So any living being, we're always going to round up, all right? All right, so are we clear here? All right, good deal. All right, next equation. This is, got 2 more equations to go and we're going to be good. Next equation is the most complicated looking one, but it's going to be okay. And I'm going to tell you next week, we're going to write these equations on the back of that trifold, so you always have those too. Yeah, that little thing we made yesterday, all of those important things are all going to be together, okay? All right, so here we go. Next one has to do with compound interest. So if we're talking about compound interest, we're talking about money. Now, the equation this time, as I said, it looks complicated, but as soon as we learn where everything goes, it really is not. So this starts off with A equals, so that's the amount you get in the end, equals P, parenthesis, 1 plus R over N to the NT. I know, it's okay. It's all right. P, we're going to start with that. P is your principal. It's your starting amount. How much did you deposit into the account to begin with? See, same as what our A was before, right? R is our rate as a decimal. Again, same thing we did before. N. N is the number of times a year. So, if I were to say the word annually, good. Annually means once. What if I said weekly?
52.
How many? 52. Oh, 52, yes. 52. What if I said monthly? Good. That would be 12 times a year. What if I said quarterly? Good. All right. So those are your N values that could happen. Oh, what if I said daily? Good, 365. All right. And then the last variable we have up there is the letter T. T is the number of years. So we just have to put everything in the right spot and type it in our calculator. All right. So here we go with example, what am I on? 5, thank you. I don't know how I forget so quickly. Example 5. Example 5 is going to cover your 15 through 22. I'm going to tell you that you deposit. So that's your starting amount, right? You deposit, let's say $5,000. Compounded, let's start compounded quarterly at 6% for, let's do 10 years. So if you could deposit the money and not touch it for 10 years. I'm going to plug this into our equation. So A equals, how much are we starting with? 5,000. Parenthesis, 1 plus. R, how do I make 6% into a decimal? Good, 0.06. Over. We have quarterly written here. How many times did you guys tell me that was? 4. And then in my exponent, I have 4 times the number of years, which is 10. So now we're all going to grab our calculators. We're going to find out how much money we have if we don't touch it for 10 years. 9,070.09. We're always going to cut it off after that last number. A bank is not going to pay you more than you have earned. It's not going to round up. Make sure that you are able, that you got that answer when you typed it all into your calculator. All right, let's try another one real quick. So underneath the same thing, let's say our P equals 2,000. So our principal is $2,000. We're going to say compounded annually at 5.5% for 5 years. All right, so we start with A equals. Our principal, our starting amount is 2,000. Then we have 1 plus. How do we make 5.5 a decimal? Yes, 0.055. Remember, we swipe this over twice and fill it in with a 0. Over. Go ahead. Jackson, you got a question?
No.
Okay. Annually. Tell me about annually. How many times is that? Once. And then in my exponent, it is 1 times 5. So again, we're going to grab our wonderful yellow calculators. Hopefully when you type this in, that's definitely not a dollar sign. Hopefully you got $2,613.92. Okay? So this is all of those problems, this is all you're doing. All right? You're just putting everything in the right spot, putting in your calculator, writing down the number. Any questions? I have one last example then that's going to cover number 27. All right. So for the last one, if it is decaying or it's decreasing, or another word that means both of those is depreciating. That means that it's going down. This is how your equation changes. Before we had y equals a times 1 plus r. Because it's decreasing, we're going to go 1 minus r to the t. All right, so this is our very last example. Example number 6, and I am done. So let's say you purchase a car for $12,000. And it depreciates by, let's say 9% each year for 5 years. What is your value of your car? What is the value? All right, so we have y equals 12,000. Parenthesis, 1 minus 9%, we're going to write as 0.09 to the 5th power. All right, I got 7,488 and 38 cents. Did 0.09. So here's just a couple things I want to mention. All right, so this is just like number 27, the very last one you have to do. So if you were to buy a car, which happens to lead us into our project, right? We're going to be buying a car. After you spend 5 years making all the payments to pay it off, this is all it's worth when you're done. Okay? So if you happen to spend $12,000 on a car, it's actually going to be more than that once you put interest on it. Not worth a whole lot when you're all done. Okay? I want you to remember that when you drive a car right off the lot, it depreciates immediately. All right? So keep that in mind. So the other thing I want you to kind of do over the weekend in your spare moments is you can start to look into insurance for your vehicle. In order to find the insurance, you need to know the make, model, year, right? You need to know all that stuff about your vehicle, and I told you to keep all that. Give me a copy, and then keep all that, and start looking for your insurance. Okay? The easiest place to find insurance is under e-insurance. Okay? E-insurance. Yes, e-insurance. E-S-U-R-A-N-C-E. Okay? All right. I know. So, just a minute. Last thing I'm going to tell you is when you're looking for insurance, do me a favor. Do not give them, because you're all minors, you know what I mean? Do not give them your real address. Do not give them your phone number. If you give them your email, they will bother you to sell you insurance 3 or 4 times a year forever. Okay? So just keep that in mind. You do not want to give them your real address or anything. They do need to know an address of the area you're at simply because insurance is different here than in the city. Why do you think insurance would be different, let's say, for collision from here to the city? Correct. What about comprehensive is when, like, nature strikes your car, so like a deer or something. Where would that be more expensive? Here, exactly. So that's why they need to have an idea of where you live. That's why they ask you those questions, but just don't give them the real one.
What about if you go in the ditch and it was like just your fault, just you on the road and you go in the ditch? Do you get insurance for that?
Well, if you're paying insurance, they will repair your car after you pay a deductible, yeah. Yeah. A deductible is depending on how much you want to pay in. You have to pay that amount first before they'll fix it. Yes. All right, any other questions? And we'll talk more about this because you guys are going to have questions once you start looking. All right? So homework, 9 through 27 all. We got this.